All right, this is section 1.1, solving simple equations. In this section, what you're going to be working on is solving simple equations using addition, subtraction, multiplication, and or division, and ultimately you're leading up to solving real-life problems. So this first slide here has two fill-in-the-blank problems. It says two operations that undo each other, such as addition and subtraction. These operations are known as inverse operations. So inverse operations are operations that undo each other. Inverse operations. Next, we have when you perform the same inverse operation on each side of an equation, you produce and the answer here is equivalent equation. Equivalent equation. Just move that down out of here. And these equations had the same solutions. So that is what we're going to be using on every one of these problems. We're going to perform the same inverse operation on both sides of an equation to produce an equivalent equation and ultimately solve for a variable. The two properties we're going to use right away are called the addition property and subtraction property of equality. What this says is if you add the same value to both sides or subtract the same value from both sides of an equation, the equation remains true. So in this first example, we've got x minus 7. It says we need to solve. And ultimately, solving means get the variable by itself. Get the x by itself. Get x by itself. Get x by itself. So obviously, this is not solved for because x is not by itself on one side of the equal sign. It needs to be by itself to be solved for. So you need to solve the equation. We're going to use those inverse operations. So just ask yourself, what undoes subtracting 7? Or what is the inverse operation of subtracting 7? And the inverse operation of subtraction is addition. So we're going to add 7 to both sides and produce an equivalent equation. So in other words, what we just did is turned minus 7 plus 7 or negative 7 plus 7 into a 0. So that eliminates that 7 from the left-hand side and moves it onto the right-hand side. So what we end up with is x all by itself, so it is solved for. The equation is solved for x. So we have x equals negative 2 plus 7, or 7 minus 2 equals 5. So that is our answer. And it does say in the directions that we have to double check your answer. So we're going to plug 5 back in, or substitute 5 back in for x, and make sure that we get a true statement. So I'm showing my work here. I'm going to double check that 5 is the solution. We end up with negative 2 equals negative 2. Since this is a true statement, I know that the answer x equals 5 is correct, and we solve that using the addition property of equality. So that is my justification for that step. On the next example, it is going to be similar, except on this one we've got addition to start, so we have to use the inverse operation of addition, and that is subtraction. So again, we're trying to make this positive 2.5 into a 0, so it is eliminated from the right-hand side of the equation, and y will be all by itself, and again, that means the equation will be solved for y. So we need to undo addition. The inverse operation of addition is subtraction. Subtract 2.5 from both sides of the equation, and create an equivalent equation where y is by itself. So 0.5 minus 2.5 is negative 2 equals, and now y is by itself. And the conventional way of showing your answer is to put the variable on the left-hand side, so I'll say y equals negative 2. There's my answer. Circle that. And again, justifying my step, I'm using the subtraction property of equality. That is my justification for doing this step. And also checking my answer. I'll just double check my answer real quick here. Just like the last one, we're going to substitute negative 2 in for y because it says y is negative 2. So 0.5 equals, instead of y, I'm going to substitute in negative 2. And I still have plus 2.5. All right, simplify by combining like terms on the right-hand side. So negative 2 plus 2.5 is the same thing as 2.5 minus 2, and that is 0.5. That is a true statement, so I know that y equals negative 2 is the correct solution. All right, one more here. This is, again, the same setup. We have a variable, a single addition or subtraction sign, and a number. Now in this one, yes, it is fractions, but it's going to be the same process. So don't freak out just because you see a fraction. Go through the same process. Ask yourself, what undoes this operation? What undoes subtraction? And of course, that's addition. So I need to add 1/3 to both sides of this equation. And this one's not so bad because we already have common denominators. These are both 3's in the denominator. So that means we can combine these using addition or subtraction by just combining the numerators. So we end up with g by itself. So we're going to solve for g, get it by itself. G equals negative 2/3 plus 1/3. In other words, 1/3 minus 2/3. You just do 1 minus 2, which is negative 1. And those are both in terms of thirds, so we still have the denominator of 3. So that is my answer. My justification for that step is the addition property of equality, adding the same value to both sides, and ultimately solving for g by getting it by itself. And then again, check your answer. So I'll just double check my work by substituting negative 1/3 in for g. So replace g with negative 1/3. We still have the minus 1/3 equals negative 2/3. Again, combine your like terms over here. So negative 1/3 minus 1/3, they have those common denominators. So to subtract the numerators, negative 1 minus 1 is negative 2. It's still in terms of thirds. And yes, that does equal negative 2/3, so I know that this answer is correct. And we can go on to the next one. This next concept for the second part of the section is using similar properties to the addition or subtraction property of equality, but they're called the multiplication or division properties of equality. The multiplication property of equality just says if you multiply both sides of an equation by a value, the equation remains true. The division property of equality, very similar. It says if you divide both sides of an equation by the same value, the equation remains true. The only condition here is that c cannot be equal to 0. You can't divide by 0. If you try to put dividing by 0 in a calculator, you are going to get an error. And I mean, that makes sense. You're trying to take two things and divide them into 0 groups. You can't do that. It's impossible. So there is no way to divide by 0. That is why we've got this condition on the division property of equality. So let's try to apply that. So on this one, again, has the same directions. It says solve. I'm trying to solve in this case for n, which means get n by itself. So how do you undo dividing by a negative 5? The inverse operation of dividing is multiplication. So what I'm going to do to both sides, again, whatever you do to one side, you must do to the other side of an equation. I'm going to multiply both sides by negative 5. And that will undo dividing by negative 5 because they are inverse operations. So the negative 5s will cancel out. N is all by itself. So again, that's what it means to solve for n. I've got my equal to. And then negative 3 times negative 5. Two negatives make a positive. These negatives are going to cancel each other out. We're just left with 3 times 5, which is 15. So n equals 15 is my answer. And my justification for doing that step, that is called the multiplication property of equality. Might as well type this out a little faster. Multiplication property of equality. And just like the other ones, we're going to check our steps, check our work here. So plug in 15 for n and double check that you get a true statement. So double check, plug in 15 in place of n. I still have dividing by negative 5. Still equals negative 3. And just simplify the left-hand side here. We have our negative sign, carry that down. 15 divided by 5 is 3. And sure enough, that equals negative 3, so it checks out. All right, example number 5, we are getting there. So example number 5, what we are going to do on this one, it might look bad right away because now we've got another symbol in here. We don't even only have an x, but we also have this symbol, which many of you know by now is the pi symbol. So yes, there's another symbol going on there, but the process is exactly the same. So don't get overwhelmed by what a problem looks like. Go back to those 4 operations, addition, subtraction, multiplication, and division, and just ask yourself, how do I undo, in this case, the way that pi is tied onto x is multiplication. So how do you undo multiplication? Of course, division. So divide both sides by pi, and that will get x by itself. So when we divide by pi on both sides, something interesting happens here. Pi over pi cancels out because anything divided by itself is a 1. So we really are just turning this into a 1 times x. It doesn't do any good to write a 1x because 1x is equivalent to x. So I'm trying to solve for x. I might as well just write x and not 1x. They mean the same thing. All right, so x equals, on the right-hand side, the interesting thing that happens here is pi cancels out over here as well. So we don't end up with a messy answer by any means. It's simply x equals negative 2. And that is my answer. I know that's my answer because x is by itself, and that's what it means to solve for x. So again, my justification for that step, I'm going to call this the division property of equality. And again, I want to type this to save a little time, division property of equality. And just like the other ones, it again says check your steps, or check your work. So double check it. Is pi times x, which is now a -2, so I'm substituting in -2 for x, is that equal to a -2 pi? Well, look at that. There's essentially no work to be done other than to say, okay, well, if I multiply two values together, I can rearrange their order. The commutative property of multiplication tells me that changing the order does not change the result when you multiply. So this, in fact, is equivalent to the right-hand side. That's a true statement. X equals -2 is the solution. All right, again, we have a fraction in this one. So this is probably the toughest thing for students to remember out of all of these problems. In this one, it is tied on to the x. That -1/2 is tied on to x with multiplication. Now, some students immediately think multiplication. All right, I need to divide by -1/2. But dividing by a fraction, it's fairly difficult to simplify. So what I would recommend, if you are multiplying by a fraction, I'm actually going to make a little note on this slide here. If you are multiplying by a fraction, the variable is multiplied by a fraction, multiply both sides of the equation by the reciprocal. And that's going to remove that -1/2. And here's the reason behind it. Ultimately, a fraction is really just two things. You are multiplying by -1, and you are dividing. A fraction bar is the same thing as the division bar. So this is really multiplying by -1 and dividing by 2 in one step. So what you're going to do is, to undo dividing by 2, we are going to use the inverse operation and multiply both sides by 2. Multiply both sides by 2. All right, that will take care of the 2, because 2 over 2 is 1. So 2's will cancel. Well, in the very same step, I'm multiplying by -1. So how do you undo multiplying by -1? You divide by -1. Divide by -1. Well, look at that. What you learned in middle school, you are actually multiplying by the reciprocal. The reciprocal just means flip the fraction around. The numerator becomes the denominator becomes the numerator. So 2 over 2 cancels out. That's a 1. -1 over itself, that cancels out. That just makes a 1. So what are you left with? Well, look at that. Just x is by itself now. So x equals, on the right-hand side, 4 is the same thing as 4 over 1. Those are equivalent values. So we're going to multiply fractions. You multiply fractions straight across. 4 times 2 is 8. 1 times -1 is -1. 8 divided by -1 is -8. And there is the answer. X equals -8. So what I'm doing here is taking care of two operations at once. I am multiplying by 2 and I am dividing by -1 at the same time, which is called multiplying by the reciprocal. And it just saves you time. You don't have to do two operations in 2 steps. You do both operations at once. And that way you're not dividing by a fraction. All right, so again, I'm going to double check my answer. If I were to plug in a -8 for x, so I've got -1/2 times x, which is now a -8. It equals 4. Is that a true statement? So the two negatives, a negative times a negative is a positive, just like the other example. We have 8, you can write as 8 over 1 if it helps you visualize how you're multiplying these numbers together. This is 8 is really just a fraction, so this is 8 over 1. 1 times 8 is 8. 2 times 1 is 2. Does that equal 4? Well, sure enough, 8 divided by 2 is 4. That gives me a true statement, so that is correct. X equals -8 is the solution. All right, there are 2 more to go. These are the solving real-life problems that I was talking about to start this video. Example number 7 here says, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. And then I even gave you a hint here for how you compute a distance based on a rate and time. It's d equals r times t, or distance equals rate times time. So I'm going to start by rewriting my equation, but I'm going to use variables instead of writing the words. So distance represents d, or d represents distance, r represents rate, and t represents time. So now we have to pick out the information from the problem, and that's really the only new piece on this, is that we need to input information from the given word problem and then solve for the variable. So it says it was a 200-meter dash, so we know right there that our distance is 200 meters, so I can plug in 200 for d, or distance. I still have my equal sign. It tells me right here the time is 19.32 seconds, so I don't know the rate, but I do know the time. The time is 19.32. So I'm going to plug that in for t. And then just like all of the other problems, we need to solve the equation because it says write and solve an equation to find the average speed or rate, so we're trying to solve for r. So all we have to do is use the inverse operation of multiplication, which, as we've said already, is division. So we're going to divide both sides by 19.32. Divide by 19.32 on both sides. Anything you do to one side of an equation, you must do to the other. And again, we create a 1. Any number divided by itself is 1, so that will cancel out. 1r is the same thing as r, so I'll put equals r. And then 200 divided by 19.32, 200 divided by 19.32, and that gives me about 10.35, and the directions do say round to the nearest hundredth, so 10.35 will be my answer. 10.35, 10.35, and this was an approximation, so I do need to indicate that using the approximately equal to symbol. And just like before, the conventional way of writing your answer is to put the variable on the left. And by the way, you're going to see me use this symbol quite a bit throughout the year. This double arrow actually is a math symbol, which means implies. So 10.35 is approximately equal to r, implies that r is approximately equal to 10.35. Just switching those around. So there's my solution. Now, because this is a word problem, one more thing that I need to do on this problem is to write a sentence. In this case, I'm going to type my sentence. But to actually answer this question, it says write and solve an equation, find his average speed. So I'm going to say Usain Bolt's speed was about 10.35, and now we run into another issue, and this is one reason why I like you writing sentences, is it makes you think a little bit deeper about the problem. 10.35 what? So is it seconds? Is it meters, miles? What is it? So we need to find some units. So let's go back to our problem. It says he won the 200-meter dash. So 200 meters, we're in meters for our distance, meters, in a time of 19.32 seconds. So if I were to go back into my work here, this is 200 meters, 19.32 seconds. I had to divide by 19.32 seconds on both sides. So right there you can see the units, meters. The division bar is per, so meters per second, meters per second. I can include that in my answer, meters per second. There's my answer, 10.35 meters per second. That is my rate. So now when I'm typing my answer out here, when you'd be writing your answer out, you can say 10.35 meters per second. And that fully answers this word problem. All right, the very last example in this lesson, it says a discounted amusement park ticket costs $12.95 less than the original price P, less than the original price P. Write and solve an equation to find the original price. All right, you can't actually do this problem without looking at this diagram down here. So you have to know the discounted price in order to do that problem. So if you're given a graphic, always look at that in detail because you might have some information in there that you need. And again, in this case, you need that. All right, so let's try to figure this one out. It says write and solve an equation to find the original price. So we're ultimately trying to find the original price. And it's defined in the problem as P. So P is defined as the original price of the ticket. All right, so let's set up an equation for this. So it says a discounted amusement park ticket. So again, I need to use another variable, so I need to define my variables before I use them in an equation. So the discounted amusement park ticket cost $12.95 less than the original price P. So I'm going to say the discounted ticket price is D. Discounted ticket price is D. So anytime you use a variable, make sure you define it before using it. In the previous one, they were all defined for us. In this one, we're defining them ourselves, so make sure you write this out. And again, this is another math symbol. Using a colon symbol in math, that is defined by. So P is defined by, or D is defined by, followed by what it actually means. All right, so to write this equation, we have the discounted ticket price, D, is, and it says right here, the discounted ticket costs, or is, $12.95 less than P. So $12.95 less than P means we're taking away $12.95 from P, so I need to write P minus $12.95, 12.95. So there's my original equation. Now again, if you don't use the information given to you in the diagram, that's where you get stuck. So you need to go to this for additional information. So the discounted price is $44, so I can plug in 44 for D. So 44 equals P minus 12.95. And then we solve that simple equation. So again, we're right back to where we were for the first few examples. How do you undo subtraction? And of course, you add. Addition is the inverse operation of subtraction, so we add 12.95 to both sides of the equation to solve this equation for P. All right, the 12.95 will be eliminated from the right-hand side of the equation. P will be by itself, so that means it is solved for P. And then we would add these two values, those two like terms on the left-hand side, to get our answer. So 44 plus 12.95 is $56.95. And that is P. And again, what does the variable P represent in this problem? Well, just look back to when you defined it. P is the original ticket price. So now we can write our final answer. The original ticket price is $56.95. And again, writing the sentence to fully answer the word problem. And there you go. This is the assignment tied on to that first lesson.